La 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 la. La 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 la. La 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 la. La 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 la.
Here in this video, we would like to talk about magnetic length. First of all, what's a magnet is? Let's try to talk. When you say magnet here, we are actually talking about a bar magnet. So this is how a bar magnet looks like. At the edges of the magnets, there is a place where the ability of attraction or repulsion is strong, and they are called the poles. One pole, when it is suspended freely on the earth, shows the north, and the other pole of the magnet shows the south. They are called north and south poles of the magnet, right? Now, before going to the magnetic length, let me tell you one thing. There is a line that is passing through the poles, north and south poles of the earth, of the magnet. That pole, that line that is passing through both of them is being called as something like the axis, magnetic axis, right? So this line is called as magnetic axis. So what is a magnetic axis is? A line passing through both the poles of the magnet is called as magnetic axis, right? You can have another line that is passing to the center of the magnet perpendicular to the magnetic axis. This line is called something like magnetic meridian or equatorial line. It is called magnetic meridian, or simply could be called as an equatorial line. So magnet has two lines. Line passing through the poles and the center of the magnet is called axial line. Line passing to the center of the magnet but perpendicular to the axial line is called as equatorial line. Let's take that point into consideration and continue our discussion further. Our core video is regarding magnetic length. Let's talk about what do you mean by magnetic length is. So if you draw a magnet again, just for the convenience, I'm drawing it again. This is the north pole, this is the south pole of the magnet. The shortest distance between north and south poles of the earth along the axis of the magnet, along the axial line of the magnet, is called magnetic length. So this is what the magnetic length is. The distance between, the shortest distance between north and south poles along the axial line of the magnet, right? So we generally treat these things in such a way that from the magnetic center, because it has two different poles who are opposite in nature, their ability of attraction or repulsion is equal, but they are opposite to each other. That's why from the center O to one pole, people measure the length as 1L. From the center to another pole, people measure the length as another L. So magnetic length generally represented as L plus L 2L. But be careful, this magnetic length is not a scalar, rather it is a vector. Magnetic length is a vector, and the direction of that magnetic length is from south pole of the magnet to the north pole of the magnet. So if we have to show, let me show with a color, different color here. Yes, this is the direction from south to north. This is the direction of the magnetic length. Be careful that magnetic length is not a scalar, it's a vector whose direction is from south pole of the magnet to north pole, from south to north. So it's a vector. But if you look little carefully, this is the physical dimensions of the magnet. But these magnetic poles are located little inside. They are not at the physical tips, they are little inside, because that's because of the formation. How does the magnet is being formed? If you go into that detail, say for example, a bar magnet has so many molecules or even atoms. Each behaves like a small magnet. So each small magnet has all north poles at one end, which together becomes a north pole. all south poles at the other end, which together becomes a south pole. So if you see little carefully, here this is the north pole, north pole, north pole. Between them there is a kind of a repulsion because similar poles repel each other. Similarly here there is a south pole, south pole, south pole. Between them there is a repulsion. Because of that repulsion, they themselves adjust a little inside the magnet. That's why you can say south pole is located little inside, north pole is located little inside. The length of that magnet is, this is the magnetic length. This is a geometrical length, a physical length, right? So it's very clear that geometrical length is little higher than that of the magnetic length. So what we can say is magnetic length is less than that of the geometrical length, simply because of the internal repulsion of the tiny magnets that are there inside the magnet. So I said magnetic length is represented with a length 2L. That's less than the original length of the magnet, right? It is experimentally observed that approximately, not perfectly, it is experimentally observed that magnetic length is approximately 5/6 of the geometrical length. 5/6 of the geometrical length means what? If geometrical length measured with a scale of a magnet is 18 centimeter, then its magnetic length is 5/6 of 18. That is 6 threes. That is 15 centimeter. It is little less because the poles are little inside. This is about the magnetic length. So be careful that magnetic length is a vector who is little less than that of the geometrical length. So let me tell you one more scenario. Say imagine a kind of a magnet who is like this. This is a magnet in a semicircular shape whose radius is equal to r. This is the north pole, this is the south pole. Be clear and careful that this is not the length, not a magnetic length. Because if you remember the definition of magnetic length, that's the shortest distance. If you remember the definition, magnetic length is the shortest distance between two poles along the axis. Between two poles along the axis. So where is the axis is? This is an axis. Axis is a line passing through both the poles. So this is one, this is another one. This will be the magnetic length. So what is that magnetic length is? From here to here. You know, from here to here is one radius. From here to here is one more radius. So in this case, magnetic length is 2r, who is having a directional property from south pole to north pole of the earth. This is how we have to understand the magnetic length. Be careful, and magnetic length is independent of shape. Whatever may be the shape of the magnet, we always look for the shortest distance between north and south pole. It depends on the position of the poles. Be careful about it, right? This is what the basic understanding of magnetic length. Thank you for watching.